Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. This video is of class 12 mathematics chapter 2 inverse trigonometric functions. So everyone please subscribe my channel so that you will get the notifications of further classes. So here in this chapter we will study inverse trigonometric functions. We have already studied about trigonometric functions and inverse functions, right? So when we recall inverse functions, we have studied that only 1, 1 and 1, 2 functions have inverses, right? So that is, if a function f from x to y is a function 1, 1 and 1, 2 function, or it is bijective, defined by f of x is equal to y, then there exists another function g from y to x such that g of y is equal to x. This function g is the inverse of the function f. Okay, that is, if only 1, 1 and 1, 2 functions have inverses, right? So here we have trigonometric. All the trigonometric functions are not 1, 1 function. It is 1, 2, but it is not 1, 1 function. So here in this chapter we will study inverse trigonometric functions, right? So for that, here we will make some restrictions on domain and range of trigonometric functions, so that we will make it as 1, 1 and 1, 2 function. Okay. So first of all, let us recall domain and range of trigonometric functions. Sine function domain is set of real numbers r and range -1 to 1. Okay, closed interval -1 to 1. Here see, on seeing this we can conclude it is not 1, 1 function, right? See, there are many, see, -1 is the image of many, more than one domain, right? More than one element of the domain, right? So here sine function is not 1, 1. All these trigonometric functions are not 1, 1 function. So here we will make some restrictions on domain and range. Okay. So here let us recall domain and range of trigonometric functions. That is, sine function r, domain set of real numbers r, and range closed interval -1 to 1. Cosine function domain is set of real numbers r and range -1 to 1. And tangent r minus 2n plus 1 pi by 2 n belongs to z. Why subtracting 2n plus 1 pi by 2 except this one, set of real numbers except this one? Why? Because we know that tangent is nothing but ratio of sine and cos, right? So cos is in the denominator. So in these angles cos are 0. So if in these angles this tangent will not be defined, right? Therefore its domain is r minus 2n plus 1 pi by 2. We know that cos pi by 2. See, when you substitute n is equal to 0, you will get pi by 2, right? So that is, cos pi by 2 is 0, so it will not be defined. Therefore its domain is r minus 2n plus 1 pi by 2, n belongs to z. And its range is set of real numbers. And here secant, that is 1 by cos, reciprocal of cosec. So r minus, here also r minus 2n plus 1 pi by 2, n belongs to z, and its range is r minus, except this one, okay, set of real numbers except -1 to 1. Here cosecant, that is reciprocal of sine function, r minus n pi such that n belongs to z, r minus -1 to 1. And last one, cotangent r minus n pi. Here cotangent is the ratio of cos and sine, right? So denominator is a sine function. We know that sine n pi is 0. That is, n belongs to z. Sine pi, sine 2 pi, sine 3 pi, sine etc. Sine n pi is 0. Therefore, domain here, cotangent domain is set of real numbers except n pi, n belongs to z, and its range is set of real numbers. Okay, now let us study. In this chapter we will study inverse trigonometric functions. It is more applicable in physics and engineering. Okay, so here first of all let us study inverse of sine function. Inverse of sine. Okay, so here we know that sine function domain is set of real numbers and range is minus 1 to 1. So here sine function is not 1 1. Okay, we know that only 1 1 and 1 2 functions have inverses, right? So let us make it 1 1 by making restrictions on domain. Okay, so here in the interval minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, or minus 3 pi by 2 to pi by 2, minus pi by 2, okay, or pi by 2 to 3 pi by 2. See, in these intervals, the sine function is 1 1. See, why? Because, see here, let us take this one, minus pi by 2 to pi by 2. So, what are the standard angles? Minus pi by 2, 0, pi by 2. We know that, and its range is nothing but minus 1 to 1, right? So here sine minus pi by 2 is nothing but minus 1, right? Because sine of minus theta is minus sine theta, sine pi by 2 is 1, that is minus 1, okay? Sine of minus pi by 2 is minus sine pi by 2, that is minus 1, okay? So sine 0 is 0. Sine pi by 2 is 1. Okay. So here all the images have only one preimages. Okay. All the images have only one preimages. Therefore this function is 1 1. And all the images have preimages, right? So therefore this function is 1 2. Therefore, so in this interval, similarly this one also, okay. See, minus 3 pi by 2, you will get the minus value, that is minus 1, and interval, sine of minus pi by 2 is minus 1, minus 3 pi by 2 is 1, okay. Because the sine of 3 pi by 2 is minus 1, so sine of minus 3 pi by 2 is 1. So you will get, see, in these intervals, the sine function is 1 1. Okay, therefore we will take this interval, that is, it is the domain, and take the range, that is sine function domain is minus pi by 2 to pi by 2 and range minus 1 to 1. Okay, therefore here this sine function has inverse, that is sine inverse. Okay, in this interval, that is minus pi by 2 to pi by 2. Sine function is 1 1 and 2 2. Therefore, this function has inverse, that is a sine inverse function, sine inverse x. Okay, sine inverse function. So, sine inverse is a function from minus 1 to 1 to minus pi by 2 to pi by 2. Okay, so here, that is, here we have already studied. See, f of x is a function. F of x is equal to y. Then its inverse is nothing but f inverse of y is equal to x. We have already studied it in relations and functions, right? Inverse of a function. So here also, sine function, if sine x is equal to y, then sine inverse y is equal to x. Okay. So here, in this interchanging, when we take the inverse, domain and range will be interchanged. Okay, that is, its domain, see, sine function range is nothing but closed interval minus 1 to 1, and domain is minus 1 to 1, and range is minus pi by 2 to pi by 2. Sorry, in sine function, domain is minus pi by 2 to pi by 2, and range is minus 1 to 1. So when we take the inverse, its domain and range are interchanged, right? That is, domain is minus 1 to 1 and range is minus pi by 2 to pi by 2. Therefore, sine inverse is a function from minus 1 to 1 to minus pi by 2 to pi by 2, such that sine inverse of x is equal to y and y is equal to sine x. Sorry, x is equal to sine y. Okay, x is equal to sine y. Same as in function. X is equal to sine y. Okay, so here, so remember, see, what is the range, domain and range of sine inverse? See, this sine inverse function, it is not equal to 1 by, that is reciprocal of a sine function. Okay, See, sine inverse of x not equal to 1 by sine x. Okay. See here, it is not an exponent. It is a notation. Okay, notation of the inverse function. That is opposite operation of sine x. Okay. So sine inverse not equal to 1 by sine x, or sine inverse x not equal to sine x of raised to minus 1. Okay. It is not an exponent. It is a notation of the inverse function. So sine inverse x is a function from minus 1 to 1 to minus 2 to minus pi by 2 to pi by 2. Its domain is minus 1 to 1 and range is minus pi by 2 to pi by 2. So here, if that is sine inverse of 0. So what is the value of sine inverse of 0? Here we will write that is sine of what unknown value or unknown angle is 0. Okay. It means sine of what unknown value, that is what unknown angle that is equal to 0. We know that sine 0 is 0. Right? Therefore, sine inverse of 0 is 0. So what about sine inverse of 1? So here also it means sine of what unknown angle is 1. Okay, sine of what unknown angle is 1. We have sine pi by 2 is 1. Right? Sine pi by 2 is 1. Therefore, sine inverse of 1 is nothing but pi by 2. Okay, that's all. So therefore, here we have learned what is the sine inverse function. Sine inverse function is a function from minus 1 to range, that is domain minus 1 to 1 and range minus pi by 2 to pi by 2, such that sine inverse x is equal to 1. Next is, we will go through inverse of cosine function. We have cosine function, domain is set of real numbers and range is minus 1 to 1. Okay, so here this cosine function is not a 1-1 function. Okay, so the interval minus pi to 0, 0 to pi, pi to 2 pi, etc. In these intervals, cosine function is 1, 1 and 1, 2, that is bijective. So here we can define cos inverse function, okay, inverse of cosine function in this interval. Okay, that is cos inverse is a function from minus 1 to 1. Okay, now it is the domain. Okay, here cosine function, it is the range. Okay, now it is interchanged when we in inverse function, it will be interchanged, right? So here domain is minus 1 to 1. Okay, cos inverse is a function from minus 1 to 1 to these intervals. Okay, we will write 0 to pi. So cos inverse is a function from minus 1 to 1 to 0 to pi, such that cos inverse x is equal to y if and only if x is equal to cos y. Okay, remember cos inverse is a function from minus 1 to 1. Domain is minus 1 to 1. Closed interval minus 1, 1. And the range is 0 to pi. Okay, this range is called the principal value branch. Okay, 0 to pi, the range is 0 to pi, such that cos inverse x is equal to y if and only if x is equal to cos y. Next, let us go through inverse of tangent function. We have tangent function is not 1, 1 and its domain is r minus 2n plus 1 pi by 2. Here n belongs to z. It is the domain and range is nothing but set of real numbers. Okay. So here domain is r minus 2n plus 1 pi by 2, n belongs to z and range is r, and this tangent function is not 1, 1. And the interval, open interval, minus 3 pi by 2 to pi by 2, or minus pi by 2 to minus plus pi by 2, pi by 2 to 3 pi by 2, okay, etc. If these intervals tangent function is 1, 1 and on 2, that is bijective, so that we can define an inverse function, okay, inverse of tangent function. Therefore, the tan inverse, okay, tan inverse is a function from R2, okay, it is the range of a tan function, so tangent function. So here the domain of tan inverse is R. So tan inverse is a function from R to minus pi by 2 to pi by 2, or we can take any of these intervals, okay, that is minus 3 pi by 2, minus pi by 2, minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2. So here I am taking this one, it is the principal value branch, okay, this interval is the principal value branch. So here we can define tan inverse is a function from R to minus pi by 2 to pi by 2, such that tan inverse x is equal to y if and only if x is equal to tan y. Okay, tan inverse is a function from R to minus pi by 2 to pi by 2. It is open interval. Why? Because we know that tan pi by 2 is not defined, right? So here pi by 2 is not including, therefore it is open interval. So open interval minus pi by 2 to pi by 2, such that tan inverse of x is equal to y if and only if x is equal to y. Therefore, it's here inverse of tangent function. The domain is nothing but set of real numbers and range is minus pi by 2 to pi by 2. Next, let us go through inverse of a secant function. We have a secant function, domain is r minus, same as tangent function, okay, 2n plus 1 pi by 2, n belongs to z, and the range is r minus 1 to 1, okay, open interval minus 1 to 1. These numbers are not included in this range. Okay, so here also secant function is not 1, 1 function. The intervals minus pi to 0, minus pi by 2, and 0 to pi minus pi by 2, pi by 2 to, sorry, pi to 2 pi minus 3 pi by 2. In these intervals, tangent or secant function is 1, 1 and 2. Okay, here why minus pi by 2, here we know that r minus the set of real numbers except this one, right? Here in this angle that secant function is not defined, okay, because secant is nothing but it is the reciprocal of cos, right? That is 1 by cos, right? So denominator will be 0, right? So it will not be defined. Therefore minus pi 0 minus pi by 2. 0 to pi minus pi by 2, okay, pi to 2 pi minus 3 pi by 2. In these intervals, secant function is 1, 1 and 2. So we can define inverse of secant function in these intervals, okay. Therefore, sec inverse is a function from r minus, it is the domain, okay, r minus 1 to 1 to 0 to pi minus any of these intervals, okay, 0 to pi minus pi by 2, such that sec inverse of x is equal to y if and only if x is equal to sec y, okay. That is, sec inverse is a function from r minus 1 to 1 to 0 to pi, it is the closed interval, 0 to pi minus pi by 2, such that sec inverse x is equal to y if and only if x is equal to sec y. Next is inverse of cosecant function. We have the domain of a cosec function is r minus set n pi, n belongs to z, okay. We know that sin n pi is 0 and cosecant is nothing but reciprocal of a sine function. So here the domain is set of real numbers except n pi, n belongs to z, and the range is r minus 1 to 1. That is set of real numbers except minus 1 to 1. Okay. So here we know that cosecant function is not one function. The intervals minus 3 pi by 2 to minus pi by 2, and here mid value is minus pi. Okay, minus pi, or minus pi by 2 to pi by 2. Here mid value is 0. Okay, because we know that here it is not including, right? N pi is not included in this set, right? In this domain. Okay, therefore here the mid value is minus pi, so minus pi not included. So here is 0, so 0 is not included. Therefore the intervals minus 3 pi by 2 to minus pi by 2 minus pi, and minus pi by 2 to pi by 2 minus 0, and next is pi by 2 to 3 pi by 2. Here the mid value, that is mid angle, is standard angle is pi. Okay, so in these intervals the given this cosecant function is 1 1 and 1 2. So we can define inverse of cosecant function in these intervals. Okay, therefore cosec inverse is a function from r minus 1 to 1 to any of these intervals. So here principal value branch is this one, that is minus pi by 2 to pi by 2 minus 0, defined as cosec inverse x is equal to y if and only if x is equal to cosec y. Okay, so remember here the domain of cosec inverse function is r minus open interval minus 1 to 1, and the range is minus pi by 2 to pi by 2 minus 0. Okay, here 0 is not included. Okay, so that is according to the domain of the cosecant function. Okay, so here the domain of cosec inverse function is r minus open interval minus 1 to 1, and range is open interval minus pi by 2 to pi by 2 minus 0. Here it is not open interval, closed interval. Okay, we know that cos of, that is cosec inverse. Cosec is the reciprocal of sine. Sine minus pi by 2, that is minus 1. Okay, and sine pi by 2 is 1. So that is including. Okay, so here closed interval, all these angles are included. Okay, this minus 3 pi by 2, minus pi by 2 are included, minus pi by 2, pi by 2 are included, pi by 2, 3 pi by 2 are included. So therefore here the range is closed interval minus pi by 2 to pi by 2 minus 0. Next is inverse of cotangent function. We have cotangent function, domain is r minus n pi such that n belongs to z, because denominator in cotangent function is the ratio of a sine, cos and sine function, that is cosine and sine function. So in sine function sine n pi is 0, therefore the domain is a set of real numbers except n pi. Okay, and the range is nothing but set of real numbers r. So here also cotangent function is not one function, and the intervals minus pi to 0, 0 to pi, pi to 2 pi, etc. In these intervals, the given this cotangent function is 1 1 and 1 2. See, it is open interval. See here pi is not included. Why? Because we know that r minus n pi. Okay, 2 pi is not included. Pi is not included. Minus pi is also not included because n belongs to z set of integers. Okay, so here in these intervals, the cotangent function is 1 1 and 1 2. Therefore, we can define this inverse of cotangent function in these intervals, that is cotangent, that is cot inverse, is a function from set of real numbers to 0 to pi, defined as cot inverse of x is equal to y if and only if x is equal to cot y. Okay, so here inverse of cotangent function or cot inverse function, domain is set of real numbers and the range is 0 to pi, open interval 0 to pi. Okay, domain is set of real numbers and the range is open interval 0 to pi. Domain and range of inverse trigonometric functions. Sine inverse, domain is closed interval -1 to 1 and range is closed interval minus pi by 2 to pi by 2, and this range is called the principal value branch. Okay, so here cos inverse, next cos inverse, domain is minus closed interval -1 to 1 and range is 0 to closed interval 0 to pi. So here tan inverse, domain is set of real numbers R and range is open interval minus pi by 2 to pi by 2. Remember here why it is open interval, here pi by 2 and minus pi by 2 are now not included. Why? Because we know that tan pi by 2 is not defined. Okay, so here therefore open interval minus pi by 2 to pi by 2. Sec inverse, R minus open interval -1 to 1 and the range is closed interval 0 to pi minus pi by 2. Here pi by 2 is the mid value, right? That is pi by 2 is included, but here our domain, in our domain of a secant function, that is r minus 2n plus 1 pi by 2. Okay, therefore pi by 2 should not be included. Okay, so here 0 to pi minus pi by 2. Okay, except pi by 2. And cosec inverse, r minus open interval -1 to 1. Here also closed interval minus pi by 2 to pi by 2 and the mid value, that is 0. Okay, except 0. So here cot inverse, set of real numbers R and the range is open interval 0 to pi, not closed interval 0 to pi, because pi or n pi. Okay, r minus, we know that domain of cotangent function is r minus n pi. Okay, so n pi should not be included, therefore open interval 0 to pi. Next we will study principal value of inverse trigonometric functions. See, the value of inverse trigonometric functions which lies in the principal value branch is called the principal value of inverse trigonometric functions. For example, say we know that sine inverse is a function defined as y is equal to sine inverse x, or if and only if x is equal to sine y. Okay, so here this y belongs to closed interval minus pi by 2 to pi by 2. We know that it is the range of a sine inverse function, that is the principal value branch. Okay, so if this y belongs to minus closed interval minus pi by 2 to pi by 2, this y is called the principal value of this sine inverse function. Okay, so now let us go through some examples. Look at this question. Find the principal value of cos inverse of root 3 by 2. And we have the principal value branch of cos inverse function is 0 to pi. Closed interval 0 to pi, right? So here we have to find an angle, that is which lies in the 0 to pi. Okay, and cos inverse of root 3 by 2. So what is cos inverse of root 3 by 2? What does it mean? Cos inverse of root 3 by 2 means, see, cos of which unknown angle is root 3 by 2. From the trigonometric table, we have cos pi by 6 is root 3 by 2, right? Cos pi by 6, that is cos 30, right? So cos 30 is root 3 by 2. And let us check this, whether this pi by 6 belongs to 0 to pi or not. See, pi by 6 belongs to 0 to pi, right? So here pi by 6 belongs to 0 to pi. So here this pi by 6 lies in the principal value branch and cos inverse root 3 by 2 is pi by 6. Okay, therefore principal value of cos inverse of root 3 by 2 is pi by 6. Okay, principal value of cos inverse of pi by 6 is, cos inverse of root 3 by 2 is pi by 6. So pi by 6 is the principal value of cos inverse of root 3 by 2. See here, this pi by 6 should be belongs to closed interval 0 to pi. That is the principal value branch. Look at the next question. Find the principal value of sine inverse of 1 by root 2. We have principal value branch of sine inverse function is closed interval minus pi by 2 to pi by 2. Right? So here we have to find what is sine inverse of 1 by root 2. Sine inverse of 1 by root 2. That means sine of which unknown value is 1 by root 2. Sine of which unknown value is 1 by root 2. From the trigonometric table, we have sine pi by 4 is 1 by root 2, right? Sine pi by 4 is 1 by root 2. And this pi by 4 belongs to minus pi by 2 to pi by 2, right? This one pi by 4, that is 1 by 4, right? Quarter, that is 1/4 is less than 1 by 2, right? So this pi by 4 belongs to this pi by 2, this interval, that is minus pi by 2 to pi by 2. Therefore, pi by 4 is the principal value of sine inverse 1 by root 2. And here, see, we know that sine inverse of 1 by root 2 is 3 pi by 4 also. Right? Sine 3 pi by 4 is also 1 by root 2. But here 3 pi by 4 does not belongs to this interval, that is principal value branch. Therefore here we cannot say 3 pi by 4 is the principal value of sine inverse 1 by root 2. Sine inverse of 1 by root 2 is 3 pi by 4 is also. Okay. But principal value of sine inverse 1 by root 2 is pi by 4 itself. Okay. That is because this pi by 4 belongs to interval minus pi by 2 to pi by 2. Okay, understood? That is, here sine of 3 pi by 4 is also 1 by root 2, right? But here this 3 pi by 4 does not belongs to this interval. Okay, why? Because 3/4 is greater than 1 by 2, right? So it does not belong to this interval. Therefore, it is not principal value of sine inverse 1 by root 2. But it is the value of only sine inverse 1 by root 2. Okay. So principal value means that angle, that value should be which lies in the principal value branch. Okay. So here pi by 4 is the principal value of sine inverse 1 by root 2. Pi by 4 is the principal value of sine inverse 1 by root 2. Next question. Find the principal value of sine inverse of minus 1 by 2. So here also, first of all, let us write the principal value branch of sine inverse function, that is minus pi by 2 to pi by 2. Closed interval minus pi by 2 to pi by 2. And here we have sine of pi by 6 is 1 by 2, right? Sine of pi by 6 is 1 by 2. Here sine inverse of minus 1 by 2, right? So minus sine pi by 6 is minus 1 by 2. That is, we know that sine of minus theta is equal to minus sine theta. Apply it. That is sine minus pi by 6 is equal to minus 1 by 2. Therefore, sine inverse of minus 1 by 2 is equal to minus pi by 6. And let us check whether it is belongs to in this interval, that is minus pi by 2 to pi by 2. See here, minus 6 minus pi by 6 belongs to minus pi by 2 to pi by 2. Okay, minus pi by 6 belong to closed interval minus pi by 2 to pi by 2, because we know that minus 1 by 6 it is greater than minus 1 by 2, right? Minus 1 by 6 is greater than minus 1 by 2 and it belongs to in this interval. Okay, so therefore minus pi by 6 belongs to this closed interval minus pi by 2 to pi by 2, that is principal value branch. Therefore, the principal value of sine inverse of minus 1 by 2 is nothing but minus pi by 6. So minus pi by 6 is the principal value of sine inverse of minus 1 by 2. Find the principal value of tan inverse of minus root 3. So first of all, let us write the principal value branch of tan inverse function, that is open interval minus pi by 2 to pi by 2. Okay, and here we have what is tan inverse minus root 3. We have tan of pi by 3, that is root 3, right? That is tan 60 degree. Tan 60 is nothing but sin 60 by cos 60. Sin 60 is root 3 by 2 and cos 60 is 1 by 2. Sin 60 is root 3 by 2. Cos 60 is 1 by 2. 2 cancelled. So root 3. So tan pi by 3, that is tan 60 is root 3. So minus tan pi by 3 is equal to minus root 3. And we have tan of minus theta is equal to minus tan theta, right? So we can write it as tan of minus pi by 3 is equal to minus root 3. That is, and let us check minus pi by 3 belongs to this interval. So minus pi by 3. Minus pi by 3 belongs to open interval minus pi by 2 to pi by 2, right? It obviously belongs to this open interval minus pi by 2 to pi by 2 because we know that minus 1 by 3 is greater than minus 1 by 2 and less than 1 by 2, right? So minus 1 by 2, that is minus 1 by 3 is greater than minus 1 by 2 and less than 1 by 2. Okay, so it obviously belongs to interval, open interval minus pi by 2 to pi by 2. Therefore, we can say this minus pi by 3 is the principal value of tan inverse minus root 3 since it belongs to the open interval minus pi by 2 to pi by 2. Okay, tan inverse of minus root 3 is minus pi by 6 minus pi by, minus pi by 3, okay, minus pi by 3, and this pi by 3 belongs to the interval minus pi by 2 to pi by 2. Therefore, minus pi by 3 is the principal value of tan inverse of minus root 3. Next question is find the principal value of cosec inverse of minus root 2. So first of all, let us write the principal value branch of cosec inverse function, that is closed interval minus pi by 2 to pi by 2 minus 0. Okay. So here now let us find what is cosec inverse of minus root 2. We know that cosec of pi by 4, that is equal to root 2, right? That is cosec 45 degree. Sin 45 is 1 by root 2, so cosec 45 is root 2, okay? Reciprocal of 1 by root 2 itself. So cosec of pi by 4 is root 2. So minus cosec of pi by 4 is minus root 2. And we have cosec of minus theta is minus cosec theta, okay? So cosec of minus theta, that is minus pi by 4. So we can write it as minus cosec pi by 4, cosec minus pi by 4, that is equal to minus root 2. And this minus pi by 4 belongs to this interval, right? Minus pi by 4 belongs to the interval minus pi by 2 to pi by 2 minus 0. So this angle lies in the interval, that is principal value branch of this cosec inverse function. Therefore, minus pi by 4 is the principal value of cosec inverse of minus root 2.